Hey everyone, welcome to another Open Cluster Management Community Meetings. Today is August 16, 2024. On the agenda today, Jushin is gonna do a demo on the integration with OCM with Kueue, along with the external emissional check controller. Jushin, please feel free to take it away whenever you're ready. Thanks.
Thank you. Let me share my screen. Okay. Um, Good morning, everyone. Today, I'm excited to walk you through a key part of my Google Summer of Code project. The focus of my work has been integrating open cluster management with Kueue as an external admission check controller. This integration is aimed at streamlining the way we manage multi-cluster environments, and especially for artificial intelligence or machine learning workloads where efficient resource utilization is very critical. Um, to start off, let me give you a quick overview of the environment we are working with. First, OCM is installed on a hub cluster and along with 3 managed clusters. We could have a quick check. Good. As you can see, the clusters are all up and running. And additionally, the managed service account and resource usage collect add-ons are also installed in these managed clusters. We could check quick of the MCA, and we can see that all the managed clusters are installed with these add-ons. And what's more, Kueue is also installed on these managed clusters, which is a very important part of my work I'll be demonstrating today. We could also take a quick look. For example, on the hub cluster, under the namespace of Kueue system, you can see that the Kueue controller manager is working, and as well as on one of the managed cluster, for example, the King cluster 1. Let's see. Okay, the Kueue controller manager is also working, and cluster 2 and cluster 3 have similar setups, so we will skip checking right now. One very important thing is that with a new support from OCM that's called cluster profile, that each managed cluster has an associated cluster profile. We could take a quick look. On the hub cluster, we can see that each managed clusters has a cluster profile which contains some basic information. For example, we take a quick look of the cluster 1 cluster profile. We can see that under the status, for example, the condition part that it shows that how the managed cluster is joined to the hub, and also the status of the managed cluster available is set to true right now. And what's very important for today is that under the credential part, each managed cluster has its own secret, which is name of Kueue admin cluster 1 kubeconfig under the Kueue system namespace, because this is a very crucial part for the setting up of the multi-Kueue environment. We will talk about it. We'll get back on this later. And with Kueue integrated into the OCM, this cluster profile status contains the credential, as we just said. We could see for each clusters, they have a secret. This secret is before using the OCM mechanism, we have to manually set up a secret for every manager cluster that we want to set in the multi-queue. And also we have to set up for each of these clusters manually a kuber config and also a multi-queue config resources. Yeah, we can see that all of the secrets are here right now generated directly with the we can directly reach them through the cluster profile API, which is really convenient. Okay, right now the most important part that OCM has implemented an admission check controller, which the most important two things do is that first, it automates the setup process of the multi-queue environment. Otherwise, just as mentioned, that the admin has to manually set up a lot of stuff, including including secrets for every managed cluster and also Kueue config for every cluster manually. But with the OCM admission check controller, these processes are all automated. And another thing is that OCM admission check controller integrates OCM placement results with the multi-queue so that the multi-queue can take the placement decisions into consideration so that we can directly select clusters based on the placement decisions, and then multi-queue can adjust itself by when the placement changes. Let's see two different cases where we could talk about this thing more clear. For example, first case one that we trying to configure the multi-queue for cluster with GPU of the type of NVIDIA T34, for example. And first, after using the OCM admission check controller, we use a different configuration file for setting up the multi-queue. We could take a quick look. As we see here, the admin, after our mechanism is used, he still needs to, for example, set up the resource flavor and set up the cluster queue. Most importantly, he should add up two additional admission checks. First one is the multi-queue, which was generated was taking control of the multi-queue config, and also another one is our OCM multi-queue admission check, which takes the placement into its parameter into consideration. So after that, we apply this placement. For example, here the placement will be taking place in here as one of the parameters of the OCM admission check controller. And for this case, we want to use this placement which selects clusters which has accelerator type NVIDIA Tesla T4 as labeled. And okay, let's move on. We first need to bind the clusters we want to set to the queue to under one namespace, which is the queue namespace. Let's verify it. Yeah, right now that the three managed clusters are all binded under the queue system namespace. Now let's apply the placement. Yes. Right now, since we already have the placement, let's check what the placement had been selected. Okay, we can see here right now the placement sample one here has been success configured, and the select clusters of cluster 2 and cluster 3. This is because these two clusters are labeled with the accelerator we want. We can have a sanity check. Yeah, for example, here the cluster 2 has accelerator equals NVIDIA labels, and also cluster 3, well, why cluster 1 doesn't have anything, so it is not selected. Yeah, after that, we have to apply the multi-queue set of configuration, which is the YAML document we seen before here. And right now we're trying to apply for it. We can see that flavor and cluster queue and all other resources we need are created. Yeah, we can try to see the multi-queue config here, which is the OCM multi-queue config. Let's take a quick look of this config. Okay, this OCM multi-queue has auto-generated a multi-queue config, and also it select clusters based on the placement decision. Here you can see that clusters 2 and 3 are selected into the queue. Okay, let's check the status of the multi-queue clusters before admitting any workload. For example, first, the multi-queue clusters, which are this cluster 2 and 3 are also auto-generated by OCM. And let's check the multi-queue clusters status. Yeah, we can see that both clusters in the multi-queue has an active status. And let's check the admission checks. Okay, the admission check is active, and inside of this multi-queue, and everything is working. And in our OCM multi-queue admission checks, it says also like a multi-queue config and multi-queue cluster is generated, and with an active status, which means that everything is working well. And especially we have a cluster queue and as well as a user queue. A user queue is basically configured in every managed cluster, and cluster queue too. When the workload is sending to the multi-queue, it first got reserved in user queue and then also reserved in cluster queue, and then spreading to the clusters in the queue. Let's finally create a job to submit to the multi-queue. For example, we try to create this job, which will be labeled to add inside of the user queue, and also requires 1 CPU and 1 GPU. Okay, right now the job is created, is admitting into the multi-queue, and let's see which cluster took the workload. Not cluster 2. Let's maybe see cluster 3. Oh yeah, good. See the as we can see that this job has been admitted and deployed in the cluster 3, and it was reserved in this cluster queue and also taken in this user queue. Because why cluster 2 doesn't have any workload is that the working mechanism for the queue is that it first create workload in every cluster in the multi queue, as long as one cluster has been as long as on one cluster the workload has been working, other workload on other cluster will be automatically deleted. Okay, good. Let's see another case that's with configuring multi-queue for clusters with more available GPU. And also this GPU must be labeled as NVIDIA Tesla T4. This is another use case. And let's add a bit of the background because the demand of optimal resources utilization, multi-cluster workers are continuously seeking to leverage OCM with multi-queue for intelligent cluster selection. For example, as an admin, my goal is to select cluster with the most GPU resources, convert them into the queue, and deploy my workload. And what's more, this approach also enables dynamic workload scheduling because multi-queue is integrated right now with OCM. It adjusts by the results of the OCM placement. So, for example, when the score has been changing among the clusters, some clusters might no longer be chosen, some cluster might be chosen again. So this multi-queue adjusts by the placement results changes to enable a dynamic workload scheduling. And in this case, the resources usage collect add-on is very essential. Let's see. First, they are also installed. We can see that under cluster 1 that the pod of resources usage collect agent pod is running. And we also skip for cluster 2 and cluster 3 checking. Okay, right now we want to select clusters with more available GPUs, and we select this cluster through add-on placement score, put this as a criteria in the placement. Our add-on placement score has a range from -100 to 100, and a higher add-on placement score indicating that this cluster has more GPUs available. And we talk about one workload is in the last case running on one of these two clusters. I think it's running it's running on cluster 3. Yes, I think so. Okay, good. And in this environment, cluster 1 has no GPUs, while cluster 2 and 3 both each have 3 GPUs. We could check through the managed cluster their allocatable and capacity. We can see that for cluster 1 there are no GPUs shown, and for cluster 2 has 3, and cluster 3 also has 3 GPUs. Now we check for add-on placement score. Yeah, for as we thinking like cluster 1 has no GPUs should have a score of -100, and those cluster has a workload running because the GPUs has been consumed should has a lower score. Let's have a sanity check. Yes, for example, because right now there is a workload on cluster 3, so cluster 3 basically has a bit lower score than cluster 2, although they have same amount of GPUs. And next, let's apply a new placement policy to reflect these changes that they select, how they select clusters like differently. For example, we've seen this placement as the user story as what we want. We want to select clusters has like the highest, the highest score in GPU cluster available, which indicating more GPU resources, and also the accelerator should be labeled with NVIDIA Tesla 54. Let's apply this placement. Okay, after this placement has been reapplied, I think we could check, for example, the difference. Yes, same. Right now we have changed placement simple 1, and we try to select between the highest GPU score and also label with NVIDIA T4. It means that the cluster 2 will be selected because as we seen before, that cluster has a higher score, and only cluster 2 and 3 has been labeled with NVIDIA T4, and so that's why cluster 2 has been selected this time. Let's see how the multi-queue was being updated. Wait a bit. It might take a bit. It might take a small moment of it to be updating. Uh, well, sorry, it might take a little bit time until the multi-queue config being changed. What's going on? I don't know why it's keep showing that it has been selected sample one, cluster both cluster 2 and 3 is supposed to be have changing. Um, let's go on. That finally we want to create a job for the updated multi-queue. And for example, we try to see this job again that we apply this job again on the updated multi-queue and is again labeled with user queue demo 2 and also require 1 GPU. Let's hopefully bro. Really? Um, placement under the sample one should be selected with. Oh my god, I don't know. It works before.
It seems the multi-queue didn't trigger an update. You may want to manually edit the molecule with something, and it can trigger an update.
Do you mean admit a workload?
I mean, I remember in the automation check controller demo code, it only cover a few cases to trigger the updates. In this case, it seems your multi-queue config didn't trigger an update when placement decision change.
Yes, I don't know. I think it has a little bit problem because a few moments ago it was working. And let me see.
Probably just label the multi-queue configurations so it can trigger an update on that. So you
Yes, you can manually edit the multi-queue config in another terminal.
Yeah, I think I could patch it or something.
yes, like just adding a label and remove that label should be
Yes.
fine.
I think I've done this before.
It's not a big deal, Jishin. You can just talk about what you're expecting it to be, what's you
Um,
expect to happen, and then we can always, loop back when the demo is ready.
um, thank you, but maybe let me first try to Patcher maybe type with let me delete this cursor 3. Let me, oh, no way. Maybe this works.
Do you have multiple monitors? Because the screen is not really moving, at least for me.
Really? Wait a second.
Yeah, I can only see your. I only also can see your original monitor.
Does it work right now?
Yep, it looks better now.
Okay. For example, I might be trying to don't know. So I'm very sorry, don't know what's going on here. Could it be really patching for let's just get back to this demo, and after I create this job again, it should be because only cluster 3 is right now getting out of the multi-queue and cluster 2 is selected, so that the workload should be right now happening, showing in the cluster 2, and here the deliverables should be like cluster 2 and cluster 3 all have this workload, and not sure if right now the cluster queue has been changing or still not triggered. Oh yeah. Right now the multi-queue has been triggered to select new clusters based on, because our placement has been changed, that we select one cluster with the highest GPU score, and so that cluster 2 has been selected. We could maybe try to deploy the work again. And we can see that, for example, we check the workload again. Yes, right now we can see that this job, dummy job 6R SNT is right now configured in the cluster 2, because right now there's only one cluster in the multi-queue. And we can see that on cluster 3, there's the former job that has been deployed in the cluster 3. Okay, this is basically what I'm talking about right now. So, thank you for all your attention, and I'm sorry there's a little bit delay on the updating of the multi-queue config, but right now it seems that it works after the placement had been changed. Yes. Sorry for a little bit drama in between, and that's all. Thank you.
Yeah, thanks, Drew. This is a really great demo. So one question that we also discussed with someone also on the training, like they were saying something like during the ML training, they also want to do something similar as bin packing. It's a little bit than just find the GPU with the highest score, but more like find the GPU that has capacity, sufficient capacity, but just to fit the request. So in that way, we can still have the GPU with higher volume in the other cluster for the larger job in the future. So is it possible, in your opinion, we can also do that in the similar mechanism here?
Thank you for your question. As I understand it correct, for example, there was a job want a small GPU, for example, just one GPU, but two clusters. One cluster has, for example, 10 GPUs, and the other cluster has 2. So we basically choose the cluster 2, which has 2 GPUs. So we save the one cluster or one node that has 10 GPUs, large GPUs for example, for larger work later on, so that a job that later on wants to deploy in this environment, the 10 GPUs can be preserved for it.
Yes. So it's more like we just fill the capacity, fill the bin with the least bin as much as possible, then go to the next larger one.
So basically, you are saying that we're trying to find the best fit for the job. It has to be enough, but the smallest one enough, so that other big places can be reserved. This I
Right.
have been thinking of. Maybe there are 2 ways. Could I please share my screen again, if you don't mind? For example, this is this basically, I think this basically has something to do with how you design the resource usage add-on, how you design the GPU score. And I try to design 2 kind of scoring. For example, the first one is like the no scope score, which means that we calculate the GPU score based on the largest node that in the cluster has largest available GPUs. And there is another kind of score, it's called cluster scope score, and it can calculate the GPUs based on, for example, how many GPUs are there available in the cluster. For example, a cluster has 3 nodes, each of them has 3 GPUs. And the most available node has 3 GPUs, and while others are all being taken a little bit. So by the no scope score, it will calculate the score with the 3 GPUs node, because it is the largest there. And the cluster scope score will be calculating, for example, the whole cluster has 9 GPUs, and for example, 2 are consumed, and right now 7 will be taken into the calculation. And I think from your use case, for example, the first thing is that maybe we could try to select a no scope score, the lowest no scope score, which means, for example, we have 5 cluster, we set the weight not to 1 but to 5. So we find the lowest score node, no scope score to deploy our workload. This has like one benefit is because that the no scope score is calculating the maximum available resources node on each clusters. So if this is enough for the workload, then it will be really fine. If the cluster or the node we are selected by the placement is not enough for the job, because we just blindly choosing the lowest one, it might be having a little bit problem. So maybe we could set up, maybe we can set up also part of the logic, maybe in the calculation logic, we can transfer the job request, how many GPUs the jobs are requesting inside of the calculation code, and then we see if the job requesting GPUs are enough for our available nodes, and maybe we skip checking for the nodes who are not sufficient for this job, or simply gave them a score that using this chosen strategy that can never reach. Yes, and I've been thinking another one way is simply choosing the lowest node scope score. But another way of thinking is that maybe we could try to find the best fit for this cluster, best fit for this job. For example, we iterate every node on every clusters and try to find out the smallest node, the smallest place, but enough for this job to be deployed. I think this works. The performance might be working the best because we can definitely find the smallest. We can find very specific which node is the smallest, but yet best fit for this job. But it might taking a lot of time because we have to iterate and search every node inside among all the cluster. It might be kind of time consuming for the score generation. Yeah, this is basically two of my ideas right now.
Gotcha. Thank you.
Yeah. Thank you too.
Thank you, Jishen. Are there any other questions for Jishen or comments on this great demo? If not, thank you everyone for attending. See you next time. Take care.
Thank you.
Bye.
Thank you.